we're going to do learning targets 11 through 13 today, but I really should have just combined it all into one. 11 and 12 are basically nothing, and then learning target 13 is really the whole crux of what we're doing today. Learning target 11 and 12 are just mostly vocabulary things, and we're going to talk about that very, very quickly. So common logarithms are just logarithms with base 10. Now, we talked about that a little bit when you did a Learning Target 9 worksheet. I said if it says log nothing 5, that means base 10. So those are just called common logs. So if you want to find the log of 424, that's very easy because common logs are the first button that you would see in your calculator having to do with logarithms. So if I want to find the log of 424, you just type log of 424, 2.63. No big deal. Now, an anti-log is just the inverse of a log, and the inverse of a log is an exponential function. So what that means is that I could take, since we're doing anti-log, it's just base 10, we're talking about common logarithms, I could just take 10 to the 4.8740 power. Okay, that's fine. But there's another way that we could do this that you guys would probably do anyway. If you have the anti-log of 4.8740, you could take the log we could set this equal to x. You take the log of both sides, well then you get 4.8740 equals log of x. Well, that has base 10, and so you would just use your circles and have 10 to the 4.8740 power equals x anyway. It's all the same. Here again in this section where we're focused specifically on common logs that have base 10, so to do an anti-log, you just do 10 to that power. If you forget, if you look above the log button, second log, you get 10 to the power. So it's there for you to help you remember the inverse. We have 74,816.95-ish. Okay? So the logs and anti-logs you can find in your calculator really quickly. Now, the next thing I want to talk about quickly is change of base. I know that most of you fancy calculators, and there is a log button in your calculator that gives you the prompts for what base it is, and it'll figure it out for you in 2 seconds. That's fine. I don't have the time to go search for that. I don't ever remember where that is. Also, if you have an old calculator, like an 83 or a TI-84 that's not updated, then the change of base is for you anyway. It says you can take the log base something of some number and rewrite it with the same base, taking the number divided by the log of the number divided by the log of the base. And in this case, we're going to use base 10 because that's easy. That's the first button we see on our calculator. So for example, if I want to find log base 12 of 18, instead of going to search for that button in the calculator, you can do log of 18 divided by log of 12. And these are both base 10. So in about 2 seconds on the calculator, I can go log 18 divided by, well, not squared. What is that? Jeez. Okay, divided by log of 12. Oh, it still had that stupid thing on it, didn't it? The stupid exponent. Log 18 divided by log of 12. 1.163. I think that's easier to do than having to search out that button. So again, log base 8 of 15, you have log base 10 of 15 divided by log base 10 of 8. Just hop on over here and type that in. You have to go search for any buttons. 1.302. Okay? That's a change of base formula. That's kind of an old formula that's gotten a little bit out of date because the calculators have gotten super fancy, but I still think it's worth mentioning. All right, so that's learning target 12. Again, learning target 11 and 12 weren't super fantastic. But learning target 13, this is good stuff. We've been solving equations and inequalities. This is going to be the third time. In learning target 3, I gave you exponential functions where there was variables as the exponents, and all you had to do was change all of the bases to match. So they were easily manipulated. So if it was a 3 to some power and a 9 to some power, you could change the 9 to 3 squared. Okay? And then in learning target 9, we talked about if you have log on both sides and it has the same base, then you can drop the logs off and you can just solve the equation. Well, learning target 13, we're kind of doing learning target 9 to the next level. Okay? So if you look at this first example, I've got 2.2 to the x minus 5 power equals 9.32. So I can't use what I did in learning target 3. There is no way I'm going to be able to manipulate these numbers to have the same base. Right? 2.2 to the second power is not 9.32. It's not going to work that way. So I'm going to have to use logarithms. By using logarithms, I can use a logarithmic properties, and I can get the variables out of the exponent. That's the whole goal. I can't solve an equation with the variables in the exponent. So I'm going to take the log of both sides. So that gives me log of 2.2 to the x minus 5 power equals log of 9.32. All right. Now there's a property, and it says there's a way to get this x minus 5 out of the exponent. We've been using it just in the reverse. We've taken coefficients and rewritten them as exponents, but you can do the opposite, and you can take the exponents out and write them as coefficients. So that's what I'm going to do. And I get x minus 5 times the log of 2.2 equals the log of 9.32. These are still both base 10. That's easy. And if you think about it, these are just numbers. I can type these two things in the calculator and get decimal values without any problem. So what we're going to do is we're going to divide by log of 2.2 so I can get the x minus 5 by itself. So in the calculator, I've got log of 9.32 divided by the log 2.2. And I get 2.831. So x minus 5 equals 2.831. And then you're just solving an equation like middle school. So you add 5 to each side, and x equals 7.831. So by using the log properties, we're getting an opportunity to take the variables out of the exponents. Okay? That's going to happen. 14 and 15 are very similar. So let's do those pretty quick. 14, I've got variables in the exponent. I need to get them out of the exponent, so I take the log of both sides. If you guys don't mind, I'm going to skip the step where we write everything as log of this exact equation, and I'm just going to go ahead and use my properties to get the variables out of the exponent. So this is equivalent to x minus 2 times the log base 10 of 6. And it equals x times log base 10 of 4. So again, these log 6 and log 4, these are just numbers. So it's just something x and something times x minus 2. So I'm going to go ahead and divide out log 6. But I still have an x, so don't forget about that. So log 4 divided by log 10 base 6 or log base 10 6 is 0.7737. So I have 0.7737x. Don't forget the x. And that equals x minus 2, 1x minus 2. So to solve this equation, I need to get the x's on the same side. So I'm going to subtract 1x from each side. So I can take my answer and subtract 1. I get negative 0.226. So negative 2 equals negative 0.226x. So then I divide negative 0.226. Now figure out what x equals. So I've got negative 2 divided by this answer. I get 8.838. Pretty much the same thing as 13. There's just an x on both sides. So you got to be careful with the x on both sides. Questions about that one? 15, similar, even though it's an inequality. We have x log of 4.3 is less than log of 76.2. So I divide by the log of 4.3 because there's nothing else really going on in this question. And I have x is less than log of 76.2 divided by the log of 4.3. So 2.97. All right. So most of your Learning Target 13 assignments is going to be like that. Or it could have Learning Target 9 problems mixed in where it already has logs involved and you're just trying to rewrite the problem, etc., etc. But some of them are a little bit complicated, so that's why I brought in this last example. Okay, so it might take a little bit of work, but rest assured your entire homework assignment is not like this problem. So first I have an issue with is there's a radical. I don't want a radical. Radicals are a disaster. I can deal with the exponents because I know how to make those come out. I know how to get variables out of the exponent. I do not know what to do with this radical. So the first thing I'm going to do is I'm going to rewrite this problem with a fractional exponent instead of a radical. And so the fourth root is the same thing as the 1/4 power. I also don't really like that I have this exponent being multiplied by something. It looks like a little bit much. So I'm going to go ahead and multiply the exponents. That way it's all one thing. Okay? I can't do much else though. I can't multiply the 2 and the 4 because of the exponent. I've got variables in the exponent, so I need to get those out. So my only option is to take the log. Okay? So on the left-hand side, you have x minus 3 times the log of 3. But then on the other side, it's a little bit more work here, okay? We have two things being multiplied. If you think back to our log properties, when we condense, it resulted in you multiplying the log being added. So we need to rewrite this as an addition question. Log base 10 of 2 plus x minus 1 over 4 times the log of 4. Okay? Now, again, it's important to remember that these are just numbers. And if you want to go through right now at this very moment and change them all to decimals, you can. That's completely fine. It's okay. Because I'm an inequality and I have this fraction right here, I prefer not having to cross multiply or do anything crazy later. So I'm going to go ahead and multiply out the 4. You don't have to do that step. You could have solved this without doing this. But I'm going to multiply this entire question by 4 just to get rid of that denominator. When I do that, I have to distribute the 4. Now remember, this whole piece is being multiplied together, and this whole piece is being multiplied together. So I need to distribute it here, here, and here. And when I distribute it here, I've got this x minus 3, so I'm going to distribute the 4 to the x minus 3. So I have 4x minus 12 log 3. 4 times log 2 plus the 4 times the x minus 1 over 4 cancels out the over 4 part, so x minus 1 log 4. Now, at this point, I will go back and I'm going to change all the logs to regular numbers because I don't want anyone getting confused. Okay? So I have 4x minus 12 and log 3 is 0.477. Four log 2 is 1.204. And then log 4 is 0.602. Now it looks like it's just an algebra problem. There's no more logs. It's okay. So we're going to distribute, and then we'll go on to solving. So 4 times 0.477 is 1.908. So 1.908x minus 12 times same value is 5.725. It's greater than or equal to 1.204 plus 0.602x minus 0.602. Okay, so first thing we're going to do, get all the x's on the same side. So I'm going to subtract 0.602x. I know this is a lot, I'm sorry, but it's just a really long algebra problem, really. I mean, there's not, once you get past the log property part, there's not much to it. It's a lot of rearranging of some things. So we get 1.306. So that means on this side, we just have 1.204 minus 0.602. So that's 0.602. Could have figured that out, I guess. All right. So then all you have to do to finish this is add 5.725. We're almost there. Plus 5.725. So 6.327. And then divide by 1.306. And then x is greater than or equal to 4.84. I mean, that was quite a bit of work. All right. But again, once we got past the log stuff, it was just an algebra problem. So don't fear learning target 13. Most of them aren't this long, but do be able to use those log properties to your advantage. Okay? So that is learning target 13. We're going to finish the unit tomorrow probably, but the rest of the unit is pretty much the same thing we just did, but with natural logs. So we're not doing too much new information before the next quiz. Okay?